Okay, welcome everybody to today's STRIDE webinar, Human Factors Research at UFTI, Current Research and Future Directions. The STRIDE Center is the 2016 USDOT Region 4 University Transportation Center. We are a consortium of 10 colleges and universities with the University of Florida as the lead institution. Today's webinar introduces the Human Factors Group at UF. We invite you to submit your questions through the chat box at any time during the webinar. Today we will have a sequence of lightning talks moderated by Alex Bond. Alex is an advisor in the Office of the Secretary at the U.S. Department of Transportation. He joins us today as an external advisory board member of the UF Transportation Institute. Thank you for joining us, Alex, and I'll turn it over to you.
Thank you, Undine. It's a pleasure to be here, and it's a beautiful day in Washington. I'm sure it's gorgeous down in the Southeast as well. And we're thrilled today to be talking about human factors in transportation. It's an important part of the research agenda for USDOT. In my role now, I cover research policy, transit, and a little bit of credit programs for the Assistant Secretary for Policy. And it's a pleasure to bring this topic to the fore and really think about how the University Transportation Centers program can move into new areas of research, bring in new disciplines into the transportation profession. You gave a quick overview of what the STRIDE Center is, but it is one of 10 regional centers in the University Transportation Centers program. Geographically situated around the country. So we're bringing together universities from multiple states to begin thinking about transportation issues more holistically. The University Transportation Centers program, though, is close to $310 million a year of research funding, very flexible funding that we hope is able to explore new topics around the country. It covers 37 centers. So imagine once you divide $310 million multiple ways, there's lots of interesting projects going on, including many of them at the University of Florida's Transportation Institute and at the STRIDE Center. So we're giving you a PetraKucha session today, although not quite in the PetraKucha format, a little bit of a taste of what's going on. I want to point out that all of these projects, the principal investigators are interested to hear what's going on out in the transportation community. They want to keep you updated. So there are project links on the UFTI website under the Human Factors Working Subgroup. And those will be updated and you can contact the PIs at your leisure to learn more about these projects, including when they're coming to a conclusion and the deliverables are out there. So let's start out with a very holistic view today with my former colleague at the Eno Center of Transportation, Paul Lewis. He is a prolific writer on this topic of where research and policy come together, written a number of papers that would be of interest to those on the webinar today. Paul is the Vice President of Policy and Finance at the Eno Center for Transportation, which is a think tank here in DC. It's one of the few organizations that's able to view transportation very holistically on a nationwide basis. And Paul's going to talk a little bit about where research intersects with public policy. And then we're actually going to take some questions for Paul right after he speaks because Paul needs to leave a little bit before the end of the session. But Paul, if we can get you up on the screen there and.
All right, hello, Alex. Thank you for the introduction. Can you hear me? All right. Okay, so thank you for the invitation to come. As Alex mentioned, I'm with the Eno Center for Transportation. We're an independent nonprofit think tank based here in Washington, and our role in this this subject is, I think, a really unique one and an important one, where we bridge the gap between the cutting edge research that's happening in institutions around the country with the actual practice in the field in the transportation system today and in the future. And that gap is public policy, right? That is how things get implemented. It's how things get incentivized. It's how things get funded. And there's really this important pipeline that comes from cutting edge research that through public policy can get into the field and into the state of practice. And I think there's also a role that we play that's the other direction, right? Where we take policymakers and their priorities, whether that's at the federal level, at the state level, at the local level, and we feed it back to research institutions to say, look, these are the big issues, these are the big challenges that government wants to help solve through transportation, and we need the research that can help push that along. So it's a really interesting time to be in Washington, D.C. in particular, because we have a new administration, we have a new Congress, there's kind of a change in the dynamics and approach and priorities that are, I think, important to understand, that are really going to define the transportation landscape for the next couple of years. So I'm just going to tick through a couple of the priorities that we've identified and some of the recommendations that we've had for the new administration, the new Congress, and translate that into, and I think a lot of you on the phone here will be able to pick up some of the human factors elements that can be addressed to solve some of these things. One of the first things that we think is going to be a big priority is climate change. It was no mistake that the president announced his pick for transportation secretary, for energy secretary, and the domestic climate czar all in the same day. Right, the energy sector and transportation sector are the biggest emitters and are going to be crucial to the administration's policy goals. And while there's been a lot of emphasis on electric vehicles and high-speed rail publicly, behind the scenes, we know that addressing the huge challenge, which is climate change, is going to involve going in at a multifaceted approach. And so what we're looking for is some really innovative ideas on how these things can work together to enact some real change. Another priority that we think is going to be top is safety, for two reasons. First, practically, we're facing a bit of a safety crisis in transportation. 2020 was a disastrous year, huge increases related to fatalities and injuries and crashes on our highway system. Some of those directly related to the fact that COVID restricted travel in many respects, and so people were traveling faster. And that also couples with long-term trends of increases in fatalities and pedestrians and bicyclists in particular. The other factor that I think makes this a priority is that it's a very personal issue to President Biden. As many know, his wife and daughter were killed in a car crash several decades ago when he was new to Washington. And it was a defining factor of his life and will obviously be an important part of his vision in transportation. And so we think that safety is going to be a big part of that, and obviously huge human factors and implications. We have some recommendations to review and reform institutions, in part to respond to COVID and also the new challenges. And a big part of that is doing things like targeting maintenance and operations to solve some of our big issues. Of course, we're going to be building things, but a lot of times the operational and maintenance approaches can get to the same goals that we have without necessitating a bunch of steel and concrete. And so we do anticipate a little bit of an emphasis on that. Transparency to DOT programs is something that Eno's talked about for a long time, enabling agencies to build faster and cheaper, incorporating land use as a solution to a lot of transportation issues. Those are all big priorities. And last, I'll say, but certainly not least, is the theme of automation. It's obviously both on the ground with automated vehicles and in the sky with drones and UAS. We've seen a lot of progress over the past decade, certainly over the last 5 years. Some of us are a little frustrated, I think, with the slowness of pace of some of those technologies coming online. And the interesting thing is that the biggest challenges are found in the human-machine interface, and those human factors are so crucial to overcoming those technological barriers to vehicle automation. And we do know that the vehicle automation can directly address some of those priorities that I mentioned earlier in this session. So we expect a lot of emphasis there. Again, translating the research that's happening all around the country into practice through policy. And so, again, I'm happy to take some questions. I think it's obviously a really important and an exciting time in transportation. And I'm really looking forward to hearing some of the cool stuff that's happening in research institutions around the US.
I appreciate it, Paul. And while people are furiously typing away, maybe I ask you to expand on one thing you talked about, some of the impacts of COVID on travel demand. You talked about speed, average speed of vehicles and how that's impacting safety, but any other conclusions that you guys have seen on what COVID has done to our travel patterns and how that might impact personal travel?
Yeah, I mean, I think COVID has emphasized individual or individualized modes of transportation at the expense of shared modes. And individual modes would be walking, biking, driving yourself in a car, versus share modes, which are bus, train, airplanes, right? And you know, I do think we'll see a huge rebound. But talking with folks in the aviation industry and in the transit agency, they'll recover some of the ridership quickly, but a lot of it will come back a lot slower. But I think the important thing to recognize with, you know, what happens in the future is that, you know, we have an option whether we can kind of sit on our hands and wait and see what happens, or we can use policy to help shape the future and get the kind of outcomes that we want. And that's where ENO wants to be involved, and I hope you all do too, and kind of shaping that future through policy, right? You know, it's not just predicting what will happen, but it's shaping what will happen in the future with the transportation system.
Appreciate that. Mondine, anything coming in through the chat box? I want to be sure that I'm looking in the right place.
We don't have any questions yet, but if you do have a question, please enter it in your chat box.
And I recognize that I gave a lot of information rather quickly. And, you know, I think a lot more questions might come up. Unfortunately, I do have to log off at about 1, but any or all of you can reach out to me directly via email. My email is plewis@enotrans.org. You can sign up for our ENO Transportation Weekly and other things that way. But you know, we are a resource to the industry, and we want to continue to stay engaged with all of you.
All right, appreciate it. Well, in case any questions come in, I'll just quickly make a preview for the rest of our session here, and we'll check the chat box at the end there. Make sure I'm on mute. There we go, off mute. So we'll end up being 6 speakers left to go. So we have quite a bit in this, but I want to highlight the diversity of disciplines that are part of the Stride Center and part of UFTI. We have speakers today from occupational therapy, which is, believe it or not, my first major at the University of Florida. Didn't end up panning out. I'm an urban planner. Planning is not represented on today's panel, but certainly a part of the Human Factors Working Group. Also have computer science, industrial engineering, civil engineering, quite a diversity of disciplines that are brought into this. And we'll look forward to hearing from each of these speakers very briefly, and then we'll take questions, I think, for the whole group at the end. There was a question that came in. Let's see. I'll just read it off. This is for Paul. Has there been any consideration on populations with disabilities who rely on public and shared transportation options?
Absolutely, and that's something that you know, has been a growing priority for policymakers and planners for a while now, and you know, something that we've been looking at. There's been a couple pilots with mobility on demand that we've been doing some research on. There's a paper called that I can happy to send around. I'll put a link to it in the chat, where we looked at how mobility on demand is addressing some of the issues with access. And it's certainly a continued challenge for public transportation in particular, as new stations and new lines are being built and others are being retrofitted. But definitely a priority and definitely an important policy piece.
I may say we'll hear a bit about the USDOT Inclusive Design Challenge here in a few minutes, as well as just an aside, there is the still under development U.S. Department of Transportation Accessible Transportation Strategic Plan, which we put out in early January and is still under development, but that is something to keep an eye on. So I guess we should begin launching into some of our presentations, considering our hour is rapidly expiring. Our first speaker is Dr. Eakta Jain. She is the chair, the lead of the University of Florida Transportation Institute's Human Factors Working Group. So she will be joining us here in a moment. So once we get the screen going, there we go. Talking a little bit about vehicle and bicyclist interactions, among other topics. So Dr. Jain, if you'd like to take it away.
Thank you, Alex. So, hi, everyone. Today, I'm going to talk about one of our recently completed projects on smartphone-based alerts to reduce speeding in school zones and near bicyclists. So intelligent school zone beacons have been installed in several locations in Gainesville. And expanding this installation presents a significant infrastructure investment for the city of Gainesville. This project looks at smartphone-based technology, which is able to connect to these beacons to alert drivers if they are speeding in school zones. So the idea is to explore how these intelligent school zone beacons as an infrastructural investment can be a foundation for safety interventions. It turns out that the same vendor also offers a phone-based app for pedestrian cyclist alert. So this project studies these two potential benefits of a smartphone-based technology that connects with intelligent infrastructure. And this, of course, connects with the national safety vision of improving safety for bikes and peds. So the project consists of a naturalistic field study where we asked drivers to drive the UFTI instrumented vehicle while wearing an eye tracker. This is a device that tracks where drivers are looking at. And when drivers were put through an initial acclimation drive, they were after that asked to drive through a predetermined circuit that consisted of 3 active school zones and 1 staged bicyclist who was a study confederate. Participants were assigned to one of 3 conditions, either a condition where the app was running in stealth mode, which means there were no alerts provided to the driver, or the condition where the app was providing audio alerts to the driver, or the condition where the app was providing audio-visual alerts to the driver. So this is an example of what our data looks like. I'm first going to play this video out for you. The purple dot that you see over here is the gaze position of the driver. So this is telling us what the focus of attention for this driver is. You'll hear the alert sound. And then you'll see the driver check their dashboard and then continue on in their drive. The black plot that you see over here, the plot line, is a plot of the speed of the driver as a function of time. Now, when we look at this data across all of our conditions, here's what we see. I'm going to very briefly just talk about the kind of very broad overall trends that we see given the lightning nature of this talk. The first thing that we see is that there are fewer speeding instances in the on conditions. We also see that there are fewer app triggers in the on condition. Remember that in the off mode, the app was still logging the data and logging if alerts should be given, even though the driver could not hear them. So we can actually compare what the app would have done. Now, this is how the driving behavior changes in terms of the speed of the vehicle. We additionally looked at what happens to how the driver allocates their attention, because attention, after all, precedes action. By looking at the eye tracking data, we're able to see what is the impact of these alerts on looking at the school zone beacon. And we find that overall, a greater percentage of drivers look at the beacon in the audio-visual on condition. But interestingly, in one of the beacons, this trend is reversed. And we think that this is because this was the only beacon that was placed overhead, and something about that placement was different, right? So this was a surprising finding of this experiment. We're also able to look at whether drivers noticed the cyclist that we had staged. And here we find that a phone-based alert gets the driver to look at the cyclist. We had 2 trips. The first trip was where the driver didn't know what to expect. So they were not expecting a cyclist to be on the side of the road. In the second trip, they kind of knew what they were going for, right? So we find the greatest gains occur when the cyclist is not expected. So to conclude, the study found that generally audio alerts are useful to draw attention to cyclists. Both audio and audio-visual alerts can lead to fewer instances of speeding. But we want to mark this with the caveat that all of our findings are based on the analysis of driving patterns of only 50 subjects, and that further investigation is needed to determine whether the alerts have the unintended consequence of drawing attention away from roadside elements to either the phone or the dashboard. With this, I thank you for your attention, and I'm happy to answer any questions towards the end. Thank you.
Thank you, Dr. Jain. Yeah, good point. We should probably have people tag their questions for which speaker they're asking it toward, because we will be filtering through 6 speakers by the end. But thank you for the introduction to your project, and also for your involvement from the computer science department at the university. Our next speaker, let's get it all up here. I'm sorry, Dr. Nicholas Napoli is part of the electrical and computer engineering department at the University of Florida. So Dr. Napoli, if you want to take it away.
Hello, actually, there we go. So my name is Nicholas Napoli. I'm in the Department of Electrical and Computer Engineering, and I'm going to be talking about applied cognitive impairment and cognitive state detection for future flight deck systems. And so the majority of our research focuses on capturing, characterizing, and predicting human physiology and system dynamics to optimize the human within a system. And so this, even though we're talking about aviation, this is translatable to vehicles on the ground, to nuclear power plants. But the reality of it is we're trying to first capture the state of the human. And so we take in as much physiological information as possible. So this could be, brain waves, it could be galvanic skin response, it could be respiration, heart rate dynamics. And we take these signals, and from an electrical engineering standpoint, we basically are processing these signals to extract information from them and essentially characterize the state of the human. And then we take these characterizations in terms of the features we develop, and we put them into a predictive model. And then we put this and look at how this predictive model is going to integrate with the system. And so this is a flight deck system. And so we're always trying to mitigate or have some type of human machine interaction. And so by doing this, this requires not just machine learning and signal processing, but some of the unsung heroes of this work are the human factors people that are helping, that we're developing these experimental designs, and it's really this kind of iterative process of going back and developing new features and developing new metrics. And so it's really a collaborative process for a lot of the work that I'll be presenting. But for cognitive state problems that exist within aviation, the 2 problems that I've been working on mostly is one area from Department of Defense applications, and so this is for fighter pilots, and so this is looking at decreasing physiological episodes. So basically, if you're flying in some of these planes, you have physiological changes that cause cognitive impairment. So this is being in high altitude, high Gs. And so this could be, in a way, translatable to the transportation industry in the sense of other things that change your physiological state, drinking under the influence, or being drunk, or drinking alcohol, marijuana use. And so things that are impairing your cognitive state. And then from a commercial aviation standpoint, basically aims at improving safety. And these are kind of cognitive state problems that are driven by the environment. So from an aviation standpoint, this is high workload situations or being distracted. And so I'm going to kind of talk about two kind of research projects, very high level, that we're working on. And so one is from the DoD application in terms of impaired cognitive states. And so one of the major problems that are occurring is that the pilots keep losing their oxygen levels, and it's related to hypoxia, and they're trying to figure out why. And so if you're hypoxic and you have enough oxygen, it's kind of, you get this kind of euphoric drunk feeling. And so I don't think I have enough time, but basically this is a video of someone in a hypobaric chamber, and they're trying to identify cards in a deck, and they're unable to identify the card that they're going through. They're that cognitively impaired. And so this is actually a flight deck that was put into an F-16 fighter jet, and it basically, the pilot passes out, and then the system basically, and they're dropping altitude, and basically the system realizes that their trajectory of the plane is changing too dramatically, and it starts lifting the plane and going out of the direction towards the ground. And so our work, we look at normal baric hypoxia, and so we're inducing a cognitive impairment by reducing your oxygen. And so during this experiment, we're reducing your oxygen and essentially making you do task-related performances geared to aeronautics. And so there are basically no task, tracking errors, comm tasks, and delay errors. And we're building these machine learning models around the features of EEG, respiration, ECG, PPG, galvanic skin response, and eye tracking to detect if you're going to make a performance change, a performance error. Likewise, we're also interested in the physiology of how the induction is changing the physiology. And so this is, to give you an example of the subject variability we see, everyone receives the same induction, and this is their O2 saturation. So basically how hypoxic they're becoming. You can see basically in subject A, we almost had to stop the experiment. Their O2 saturation became too dangerously low, where this person in yellow and subject C became nearly not even fully hypoxic. And so we look at the changes in the brain waves. We develop new algorithms using EEG to predict the level of hypoxia. So the actual physiological state you're in. From a standpoint of cognitive, in terms of state of commercial aviation, we, based off of the commercial aviation safety team CAST, they came out with a report highlighting the types of accidents and the occurrences of accidents that have occurred over the years. The largest of them being distraction. So we've developed an experimental design to induce certain attention-related human performance states. So the four we looked at are channelized attention, startled surprise, low workload, and high workload. And we developed benchmark tasks to train the ML. And we can develop a very, very good subject dependent. So you have a subject dependent model, but when generalized to a general community and using the algorithm we developed for a specific person, these detection paradigms slightly begin to fail. And we're now pushing these models into the flight deck and into a flight simulator to predict their cognitive states at these four cognitive states as they are actually in a flight simulator versus these benchmark tasks. So that's kind of the work that we're working on right now. We're developing a protocol and system for defining cognitive engagement through automation. And so this work was originally started by looking at some of the EEG metrics of how we define engagement currently. And we are developing new signal processing methods to define engagement. And you can see some of the predictive performance from the commercial aviation project. We can see some of the predictive performance between high workload and low workload in terms of state classification for the benchmark tax to increase around 16%, which is kind of driving us to develop these automation experiments that drive engagement. And so this is one of the things we're working on. And so this is one of the signal processing approaches where we look at time frequency dynamics over versus typical frequency Fourier analysis that are kind of classical in this approach. But this is the kind of work that we're doing. We're very focused on the machine learning and biosignal processing. We work with an assortment of different human factors, experts, and cognitive scientists. Thank you.
All right, thank you, Dr. Napoli. It's for those of us in the surface world, it's always interesting to see the angle on the aviation side of the transportation business. So we appreciate it. Moving right along, our next speaker is Dr. Pruthi Manjanata. He is the manager of the I Street testbed in Gainesville. For those who may be not aware, there is actually tires on the road, autonomous vehicles in place. It's kind of a unique environment for it, but helping us get some ideas on where AVs are headed. So would you like to take us away?
Yeah, thank you so much, Alex. So as Alex said, I'm the testbed manager for the iStreet program here. So iStreet is a collaboration between University of Florida, Florida Department of Transportation, and the city of Gainesville. So when we say testbed, a lot of people think that it's more like a closed facility. It's not. So it's basically the roads in and around our campus are part of our testbed. All the sensors, your roadside units, onboard units are actually deployed on the roads of Gainesville. So this is a quick look at the Florida CAV initiative. And as you can see, we are a central part of that initiative. So in the chat box, I'll leave you guys links to both the CAV initiative from the DOT and a link to our iStreet program to check out in detail. But for today's program, since we are talking about human factors, I would like to highlight a couple of projects which are both of them use autonomous shuttles. So one is the Gainesville Autonomous Shuttle operated by TransDev here in Gainesville. The other one is Lake Nona Autonomous Shuttle. Lake Nona is a small township near Orlando. It's operated by a company called Beep. So for the first one, I'm going to talk about a couple of surveys we did. And Dr. Justin Mason, who is going to speak later, his team is also doing some work on this shuttle. And for the second part, I'm going to talk about Lake Nona Autonomous Shuttle and what sort of data collection we did and how we are studying the behavior and the public perception. If you look at the two shuttles, these in the world of autonomous shuttles, these are the two big players right now. The most famous or the popular one is Easy Mile Easy 10 model. And the other one is the Navia model, which is used in Lake Nona. Both of them have very similar specification. They can go up to 25 miles per hour, but currently in most of the projects we see that it's being limited to around 15 miles per hour for safety. And both of them do have someone as a service operator, with kind of a joystick to take over the manual mode if need be. So Gainesville Autonomous Shuttle is funded through Florida Department of Transportation, although the evaluation study itself is funded by the university. The service, after a lot of initial hiccups, started in February, and we had to shut down one because of certain NHTSA directives, because of an incident that happened in Ohio with the same shuttle, and another because of COVID. And the service was relaunched in fall 2020, and it is running on Gainesville Street as we speak. This is the proposed route. So phase one is what is running right now. And we recently heard some good news about phase two, and with an eventual phase three coming up, which connects university and the depot park area. So we did a before survey back in summer of 2018 to understand the public perception before the shuttle was launched. So at that time, only a third of the surveyed folks were aware of that Gainesville is going to get a shuttle soon. But we did get a bunch of positive responses. 77% of the people surveyed at that time, they agreed that they would like to take a ride in the shuttle. We also wanted to see how the drivers and the pedestrians and bicyclists would feel sharing the road with an autonomous vehicle. So the drivers were much more confident. Only like a third of them had some sort of concerns as to how to interact with the shuttle, whereas cyclists and pedestrians were a little bit more concerned. They wouldn't know how to signal an intention. Let's say if they wanted to cross a crosswalk in front of the shuttle. And we saw a lot of neutral or somewhat responses because that's the technology that they weren't aware of, they hadn't seen or interacted with it. So a lot of the responses were like somewhat or moderately this or moderately that. But what we are seeing right now, we are currently conducting the after survey. I have some preliminary impressions from the after survey for you guys. What we're seeing right now is sort of different from what we saw a couple of years ago before the shuttle came in. Nearly 70% of the people now know that the shuttle exists and it's operating on the roads of Gainesville. But the people who want to take a ride in the shuttle are down right now. It's down by 15%. A lot of it has to do with COVID as well. It's a small shuttle with a capacity of 9 to 12 people, maximum of 15, let's say. So people don't want to share space with other people in a small box. But whoever has taken the ride in the shuttle already, like everyone feels comfortable and satisfied to varying levels of agreement. But what we did see is drivers are dissatisfied. They are not happy with the slowness of the shuttle. The speed limit is around 25 miles per hour, whereas the shuttle goes at 15 maximum. But on the positive side, pedestrians and cyclists are much more satisfied. They don't have all those confusion of how to deal with the shuttle. And people who have seen the shuttle as pedestrians or bicyclists, they seem confident to interact with it. And now, unlike the before survey, the opinions are more divided from extremely satisfied to extremely dissatisfied, as opposed to somewhat or a moderate response in the before survey. So the survey is still ongoing. Maybe these numbers will change and we have to have a comprehensive look at it, dig deep into other questions and into details. That's the status on the survey right now. And coming to the other shuttle in Lake Nona, which is operating in a township close to Orlando, there was a similar story, and the service has been running continuously since June 2020 after the COVID stoppages. The evaluation is funded by DOT, but the shuttle itself is managed and run by a company called Beep. So what we did was, here we were funded to put take some video recordings at some critical locations and to study the behavior of the shuttle itself and also the shuttle's interactions with pedestrians, bicyclists, and the drivers around it. So we recorded videos at 3 locations: a crosswalk, a signalized intersection, and a stop controlled intersections. What we saw was the slower shuttle speed here as well was leading into a lot of dissatisfied drivers, and we saw some illegal passing maneuvers or some sort of aggressive maneuvers from the drivers. And we did see that shuttle forms a longer queue when compared to the without shuttle conditions and in all these places. And obviously it leads to a longer saturation headway. That means we can only push very little volumes of traffic out of these facilities. And this is also an ongoing study. We need further analysis, and we have access to the shuttle trajectories, and we're studying it in order to get a better understanding of what sort of aggressive behaviors might come in with the human-driven vehicles when they are driving in a traffic shared with the autonomous shuttle. What we are doing is we are using the shuttle trajectories as well as the videos from the shuttle itself. So here in this example, you can see a car following the shuttle. So what we're doing is we are doing image processing, and we are tracking both the shuttle itself and the human-driven vehicles that follow the shuttle. And we are analyzing these trajectories to get an understanding of the behavioral differences between a human-driven vehicle following a human-driven vehicle versus a human-driven vehicle following an autonomous shuttle. So these are some of the examples of exciting research that is going on in the field of autonomous shuttles. So a number of cities and counties all over US are having pilot studies in this area. This is going to be an interesting window into how the AV is going to be part of our lives. And yeah, I'm excited to work on this and share some more interesting results in the future. Thank you.
Thank you, Dr. Manjunatha, and have interesting stuff going on in the real world there. So we'll come back to it after some questions. And thank you for posting a few links. We'll make sure our process keeps going. We may have to follow up with some of the question askers, but let's keep on marching. So our next speaker, Dr. Sanaz Motometty, is a faculty member in the Industrial Engineering Department. Dr. Motamedi, if you want to take us away.
Sure. All right. So, hi, everyone. I am Sanaz Motometty. I'm going to talk about our project. A recent funded project, optimizing a highly automated driving system for people with cognitive disabilities. We supported from USDOT in inclusive design challenge. This is a team that we are working. We are 12 PIs from 3 different universities. The PI of this project is Alexandra Conley. She's from the University of Kansas. I am a UF lead. I'm working with Dr. Jain and also Dr. Jain that they're actually in this call, and other faculty members, Dr. Hu and Dr. Zhou, that are not actually in this call. And we're also working, collaborating with University of Kansas Medical Center and as you can see, we are a great and diverse group to work on this project. But if I want to give you a bit of overview about what is actually inclusive design challenge is basically USDOT had a call for an innovative design solution to enable people with a physical, sensory, and cognitive disabilities to use automated, highly automated vehicles. They're actually seeking solution for common barriers like locating vehicles, entering and exiting the vehicles, securing passenger and mobility equipment, and also interacting with vehicle in a routine and emergency situations. This challenge has a 2-stage. We are in a stage 1. Is we were winner of the stage 1, which is at the proof of concept, the project is started January 6th, and it's actually 18 months project. This challenge has a 2nd stage, and for your further, if you want to dig more deep in this challenge, I encourage you to look at the DOT link here. I will post it in a chat later on as well. So let's talk about our response to this challenge. So the goal of our project is develop an innovative automated driving system design that operate at the level 4 or 5 of automation for people with mild cognitive impairments or mild or moderate dementia. This population basically experiences the reduced alertness and memory, difficulty in information processing, disorientation, and difficulty in decision making, which all these makes pre-trip planning or interacting with in vehicle extremely challenging. So our design actually tried to focus on providing assistance during their pre-planning and offering guidance and communication during a normal and emergency situation that might occur during their trip. This is so we are addressing this key function that I just mentioned. So what we are actually designing, we are designing 4 different systems, and actually 3 different systems and 2 other functionalities. So to facilitate these functions, we propose to actually develop an integrated system solution, which is as I listed in a slide, as a subsystems. Number one is a travel mobile secure app that includes well-being features, trip planning features, assistance with automated driving system identifications, and provide the en route trip informations. And KU will actually responsible about to develop that. But UF, actually, University of Florida, is responsible to developing a travel monitoring system that detects the real-time travel alertness during the trip. And another system that UF is responsible to develop is creating automated vehicle agent that uses internal and external resources to resolve emergency situations and provides continuous reminders and alerts, offers a travel convenience and safety features operation, and ensures the consensual awareness during a normal and also emergency situations. And also what we are trying to, we try to basically integrate all these combine and integrate all this system using Internet of Things cloud framework that connects all and gather all the data from the various devices that runs the real-time analytics. And also we will put all those system and have a as a proposed system in a contents day, which is going to be about 17 months from now for DOT, and hopefully we're going to be a winner in a stage 2 as well. So I introduced the system that we're going to develop, and but our approach actually is having an interdisciplinary team of transportation engineers, human factor experts, including myself and my colleague from industrial engineering departments, and computer and data scientists from computer information system departments, and also health professionals that are collaborators from KU Medical Center that actually help us to have a different perspective and angle to tackle this challenge. So all these, so we have all these experts in our team, and that's actually uniquely positioned us to develop the inclusive, intuitive, and innovative design solution to serve people with cognitive disabilities. And we are planning to have a principle of human-centered design. We are addressing the user's needs by adopting an iterative design approach that includes individuals with cognitive disabilities that participating as stakeholders in our research experiments, and also our advisory board. We will engage with the stakeholders from also medical community, automotive industry, and business domain to ensure that production feasibility and maturity. And our solution is, and we hope that our solution can be integrated into the production vehicle as the original equipment. So through our strong expertise and our robust engagement with the users and advisory board, our state of art and also our state of facilities, we will positively impact the mobility, safety, and equity of life of people with cognitive disabilities. And this is, as I said, this is an ongoing project, and we are in the third month of this, and we are developing the systems, work hand in hand with end users. I will be happy to answer any question at the end. And thank you for inviting me for giving this presentation.
Great, thank you. With our ambitious agenda to put 7 speakers, let's keep on marching. Dr. Jocelyn Mason is with the Department of Occupational Therapy. So Dr. Mason, you want to take us away?
All right, let's go back 1 second. Thank you, Alex. So I'll have a quick presentation today to make sure we have enough time for Dr. Jiang at the end. I'm going to provide you with more information about tools and services that we have available at the University of Florida, specifically housed within the Institute for Mobility, Activity, and Participation. I'm Justin Mason. I'm a junior faculty member in the Great Department of Occupational Therapy, and I'm also a member of IMAP, which I just introduced. Quick acknowledgement, I'd like to acknowledge all of the members of IMAP, specifically the director, which is on the top left, Dr. Charlene Clausen, associate director, Dr. Winter, and then the rest of the team. So I'll provide a brief update on resources and tools right now. Most of our data collection occurs at the Smart House, which is located in Okamic, and that's a small community just south of the university, about 2 miles south. That would be where we have our driving simulator housed. And that is a RTI driving simulator, a full cab, as you can see on the car inside of the garage, with the 3 projection screens. And then it also has 3 LCD panels that are used for the side view mirrors and virtual dash. There's just a few more pictures to explain and to kind of show you what goes into the system. We have developed autonomous vehicle mode called SimDriver, which keeps the vehicle on the road and maintains a specified headway distance or desired velocity, very similar to adaptive cruise control. It also allows us to adjust and to go along that iteration process to improve our driving simulator scenarios by providing data, kinematic data on the fly, so that we can see what's going on and take a deeper look at it rather than analyzing everything post. The engineers in the room will love this, a nice little system diagram of all of the technology that is then integrated through the host computer and the driving simulator. Additionally, we also have developed a simulator sickness mitigation protocol, which takes into consideration a lot of different events or stimuli that may provoke simulator sickness or motion sickness. So we control the environment with the temperature. We make sure that there is cool air blowing on the driver or the participants. Scenarios are also designed to minimize complex scenes. And then we also have developed an acclimation scenario for roughly 7 minutes, but that can be toned down depending on what scenarios we have and how the drives have been developed. But they typically begin with simple visuals, slow straight driving, incrementally adding some turns, light traffic, and increasing speed. It's a good way to kind of get the participant used to our simulator and then the scenarios. We just wrapped up a 104 older driver project where not one of them dropped out due to simulator sickness. So we did something right there, which was nice, a lot different than some of my previous studies. And we also have preparedness measures, which we've developed and monitoring systems. We use the motion sickness questionnaire. Here's a brief example of it. It's just 4 domains: sweaty, queasy, dizzy, and nauseous. And it's just ranked on a VAS, a visual analog scale from 0 to 10. And we monitor that in real time while after each drive and during the drives, just to kind of check in on the participant to see how they're doing. Additionally, we have 2 on-the-road vehicles that have level 1 or level 2 automation. They have several ADAS, advanced driver assistance systems, and in-vehicle information systems. We have a 2019 Toyota Camry XLE, and it's also been fitted for our driver rehabilitation specialist, so that we are able to take people on the road. We're able to assess their driving performance, whether they are in a study or whether they just need services that are provided through our department. There's just a quick image on the 2020 Toyota Corolla LE. There's several ADAS features and IVAS features as well. I'm wrapping it up. I'm getting there, Alex. Thank you very much. And then this also has a few other advantages for the driver rehabilitation specialist. And that is whether we're teaching people to use adaptive equipment that may help them drive safely, or if we want to assess their performance, and we can use the 3-inch eye check mirror as an example for that to see if they are detecting or looking where they should be observing. Pruthi mentioned earlier that we utilize the EZ10 automated shuttle, which is a great combination of iStreet, FDOT, City of Gainesville, and TransDev. And then during that time, we've developed a few surveys and are currently developing more surveys to assess adults' perspective of autonomous ride-sharing services. There's several publications linked above. I can share my slides after. And then we've also produced a final report, which has 10 instructional models for how to use our driving simulator. And we have a few funded projects right now. We just wrapped up phase 1, which is older drivers and autonomous vehicle technology. We are currently working on phase 2, which is younger and middle-aged adults. They'll experience both the shuttle and the driving simulator. Dr. Jain will provide a brief update or a brief presentation on our pilot study, exploring younger and older drivers' trust, attention, and workload. And then we have a current project through NIH, through NIDLR, looking at people living with Parkinson's disease and their experiences with this type of technology. And then we're also diversifying and looking at the effects of medical marijuana use on driving simulator performance. Thank you very much. I'll stick around for questions, and I look forward to it.
I appreciate it. Diverse projects going on, very exciting stuff. So just real quick housekeeping note, obviously we're not going to get to a lot of questions, if any. So the direct emails for the speakers are in the chat box, and usually you might ignore some of the post webinar emails. This one's gonna be pretty rich. It's gonna have some of the presentation links as well as emails to the people who spoke. So last up, sorry to bring you at the end. By the way, I don't think the webinar self-destructs right at 1, so you can feel free to go over a few minutes. Wayne Zhang is a faculty member in the Department of Industrial and Systems Engineering. So Dr. Zhang, you want to take us away?
Okay, thank you, Alex, and good afternoon, everyone. I have a very ambitious slide deck given our time limit, but I'll try to get through it as quickly as possible. Today, I'm Wayne Zhang. I'm an assistant professor in ISE, and today I'll be talking about a study where we're evaluating the use of adaptive cruise control by younger and older drivers. It was great that Dr. Mason went before me because he already introduced a lot of the factors and project things that we're going to look at. So first, I want to acknowledge the team. So Dr. Mason Justin is the PI on this project. We're also working with Dr. Klassen, Jason Rogers, and I really want to acknowledge some of my students, Haoling Zhang and Nina Rudd, who contributed a lot to the development of this project. And it was funded by UFCTSI. So older drivers are known to have a couple challenges when it relates to driving, especially compared to younger drivers. Mostly this is due to workload, reduced response time and processing time. And one of the ways that we might be able to mitigate these challenges is by the use of automated vehicles or advanced driving assistance systems. One example system is adaptive cruise control. So adaptive cruise control controls your speed and maintains distance from lead vehicles. And this can reduce some of the cognitive demand that older drivers might face, allowing them to focus on other things like detecting pedestrians or monitoring the road situation. There are a lot of benefits of vehicle automation for everyone, but one of the challenges is that we're increasing the complexity of the systems that our drivers are using. And that requires a full understanding of the system to have appropriate usage. Some challenges for these new technologies are that people might have poor understandings or incorrect mental models of how they work. They may have miscalibrated trust in the system. They might over-trust or under-trust. And there might be cognitive overload due to the new technologies that they are now interacting with. So the purpose of this study is to compare older and younger drivers in their interactions with adaptive cruise control. We specifically targeted ACC because it is an available technology currently, and many new cars have it built in. And we want to understand whether there are differences between these two groups who might have very different behaviors. We're studying the trust, visual attention, and workload both before and after an automation failure. And we're also understanding the user's understanding of the ACC systems and their perceptions of automated vehicles before and after interaction. So I have a lot of methods here. We don't need to go into too much detail. The main things are that this is a driving simulator study. Dr. Mason had some great pictures there. We're using that driving simulator that's located in Smart House, which you can see in the bottom right. We also have multiple drives that we have our participants go through, some of which have ACC on and some of which do not have ACC on. And we are evaluating 20 younger adults and 20 older adults on a number of these different measures. So the measures we're looking at are driver characteristics like user perception, driving habits. We're measuring workload because we know that that differs between younger and older drivers using a number of different metrics, including NASA TLX and pupil width. We're measuring trust using a number of different scales and physiological measures. And we're also using driving performance measures like visual attention through eye tracking and driving performance. And I'm glad to report that we have just recently started data collection on this project. So it's very exciting. It was challenged getting this started during COVID, but we're now getting started. One of the things we sort of discovered when we were developing this project is that we needed training to help people get accustomed to the ADAS and the ACC. And we found that there is actually sort of very mixed results in terms of how this training should be delivered. The research has shown that there isn't a standardized method for ADAS training. With most of the most common methods of reading the owner's manual or scarily enough trial and error. We also found that there were differences between how older and younger adults wanted to learn about automation. Older adults preferred demonstrations at the dealership or reading the manual, while younger drivers preferred trial and error. So one of the things we want to know is, how are older and younger adults differing in their approach to using training materials? And we also wanted to know what types of training materials we wanted to provide. One of the changes that happens with ADAS is that it changes the role of the driver. But these changes are rarely explicitly told to the drivers themselves during the training. So we've actually developed two sets of training that help address this. We have basic training that looks at system functionalities, procedures for operations and limitations. This is what you would find in an owner's manual typically. And we're also building comprehensive training that introduces background about how ADAS systems work and how the driver should interact with these systems during their drives. So we've been developing this training for use in our experiments. We use an iterative approach where we started off by looking at current vehicle manuals. We developed these changes over time, and we also made sure that the language that's used is targeted at an appropriate level for use by a larger population. And after people go through this training, we were evaluating their knowledge of the ACC system through a mental model assessment. We will be measuring performance through the training using eye tracking and also the mental model assessment. So I have an example of some of the measures we're looking at. So we'll be able to figure out where they are looking and what topics they focus on during the training, whether they go back and forth between different topics. And we will also know how much time they spend on each of the pages. So we'll have heat maps based on it. And using this, we will compare the results between older adults learning to use ADAS technologies and younger adults learning to use ADAS technologies. So in terms of impacts, this research will help with the development of new educational material and also help us understand whether ACC is a useful feature for older and younger drivers. More specifically on the training side, we're going to be evaluating how people approach training materials using eye tracking. And we will also evaluate the efficacy of providing this role and responsibility information in terms of mental model development and also driving performance and safety measures. It's a bit long, but I think I got through there. Thank you very much.
I hope I didn't apply any undue pressure. It turns out that we have to reserve till 1:15.
So we have time for questions. Great.
I apologize for applying any extra time pressure. So we have a couple of questions that have come in. Feel free to type away or save some of these for direct follow-up. But here's the first one for Dr. Jain. Do you plan to look at pathways to incentivize use of the app in future studies?
Sorry, Alex, could you repeat the question?
Sure, I know I sprung that one on you. So let's see. Right. Do you plan to look at pathways to incentivize use of the app in future studies? So, yeah.
That's a good question. Up until now, our role has been to evaluate the technology and then let the appropriate policymakers make decisions about adoption or not based on a variety of factors, right? Not all of which we necessarily have visibility into. I think there's an interesting opportunity for fundamental research in that question in terms of evaluating the pathways for adoption of any kind of technology, right? Whether it's this particular technology or some other technology. And maybe that's something that would be interesting for the human factors group to think about, right? Our group is a relatively new group and is a new strategic direction for the UF Transportation Institute. And certainly this could be one of the things that we think about as an avenue for research, wherever it is most relevant.
Okay, we have a question here for Dr. Motamedi. Do you have an OEM partner? I guess it's a two-part question, so get ready. Do you have an OEM partner, any manufacturers you're working with? And then the second, how are you able to decipher Canvas messages? I assume that means the controller area network. I don't know for sure, but if that acronym works for you, please let us know. You may be on mute. There you go.
Yes, I was on mute. Sorry for that. So yes, I think we do OEM partner. I don't know. I mean, in my top of my head, to be honest, but we have advisory board that it's from different industry sectors, and also business owners, and also I'm not sure that I can share that information with everyone here, but about the how we can integrate the system. We are planning to use Canvas network for now, but it's still, we are thinking of about a platform right now, and this is an ongoing project, so we're still figuring this stuff out, but the most likely that we're going to use Canvas as a platform. Yes.
Did I get the acronym right?
Yes.
Okay, good. Remember seeing it in a presentation a while ago. I hadn't worked with it myself. So question just came in for Dr. Jain. What is the default headway for ACC on your driving simulator study? Also a two-part question, by the way. And then the second half, any different headway for older and younger drivers?
That's a great question. So we have one controlled headway distance for both our younger and adult drivers, and we set it at the 2-bar distance. So I can't remember exactly how many feet that is in our driving simulator, but we were trying to mimic sort of the following distance for 2 bars, which is the medium following distance. But we are using the same one for both younger and older adults. Luckily, Jason Rogers sent me a message. It is 2.2 seconds headway to time for the medium distance. So thank you, Jason.
The second half was older and younger drivers. I'm sorry, I was there anything on that, or did I?
We're using the same headway time for both.
Got it. So while we wait for any other questions that might come in, I want to first thank all of our speakers, and I appreciate the chance to hear drill down. So I deal every day with the big numbers of the university programs, university transportation centers, and as an external advisory board member, tend to hear about the organization of UFTI, and sometimes don't get to hear about the on-the-ground research. So this is a great opportunity to hear about them all very quickly, and these are all deserving of more significant presentations in the future. I have no doubt we'll see each other at on the conference circuit once we're back in person. So thank you again for the opportunity to moderate and to hear from everybody. Quick note, again, look out for the email that will be coming to summarize the session. There is a survey. Ondine has put that link in the chat box. Always helpful to get feedback on not only this webinar, but for the whole Stride webinar series. So please fill that out and keep an eye out for the summary email on its way. Seeing nothing else, we can give you back 4 minutes of your day. Take care, everybody, and thank you very much.
Thanks so much, Alex.
Thank you, Alex.
Thank you.